Okey, kita tengok pada collision theory. Okey. Okay. First, the kinetic theory of matter. Matter is made up of tiny and discrete particles. They are constantly moving, vibrating at fixed position for solid, and moving freely for liquids and gases. As a result, particles collide with one another. During collision, transfer of energy occurs. Fast-moving particles transfer some of their energy to slow moving particles and increase their kinetic energy. Okay, this process is repeated with other particles. So, particles do not have same kinetic energy and are constantly changing. The collision theory explains how random particles interact with one another to cause reaction to occur and form product. Okay, maksudnya sekarang, okay, for example, these particles got several particles, 1, 2, 3, 4, 5, for example. Okay, so this particle, for example, that have more energy, okay, more energy, there is fast moving particles transfer some of their energy to slow moving particles, and then it will increase their kinetic energy. Okay, for example, this particle also, okay, for example, the particles, fast moving particles, and then they collide with another particles. So when it collides with another particles, it will transfer energy to this particle, and then same goes to this particle, whereas this particle also will collide with other particles and then transfer energy to other particles. So this one they keep repeating. Okay, this process is repeated with other particles. So from this theory, they relate that from this movement of particle, from this collision of particle, so kita boleh explain how random particles interact with one another and then cause reaction to occur and form products. Okay, according to the collision theory, random particles must collide with one another for reaction to occur, and then the rate of reaction depends on the frequency of effective collision. Okay, for example, A, okay, particle of A okay, for example, if particle A collide with particle B, and then it will produce particle C. Okay, so cikgu padam balik. Okay, A react with B will produce C. Okay, and then meaning that, for example, particle A collide with particle B, and then it will produce C, meaning that this side is reactant and then this one is product. So if A collide with B and then will produce C, so meaning there is effective collision. Effective collision. But if particle A collide with particle B but cannot produce the product of C, so meaning this collision we call ineffective collision. Okay, cikgu repeat. For example, A react with B will produce C. Okay, meaning that if particle A collide with particle B and then produce C, so meaning that reaction is happen. Okay, when reaction is happen, so that's collision between A and B we call effective collision. But if particle A collide with particle B but cannot produce C, so that one we call ineffective collision. If ineffective collision happen, so meaning that there's no reaction between A and B because they cannot produce C. Okay, so from here you can see that not all collision between reactant particles result in reaction and the formation of the product. Only effective collision would cause reaction to occur. To produce effective collision, the reactant particles must have energy equal to or more than the activation energy and collide in the correct orientation. Okay. For correct orientation, meaning that you have to follow, for example, katakan kalau you ada merentas desa, okay, merentas desa larian from checkpoint A and then checkpoint B and then checkpoint C and then D. So you nak jadi winner, you kena follow from checkpoint A, go to checkpoint B, from B go to C, and then from C go to D. And then baru you boleh jadi winner. Okay. Tapi kalau for example daripada checkpoint A you pergi ke checkpoint C and then you terus pergi ke checkpoint D, maksudnya you tak follow orientation. Okay, you tak follow dia punya orientation yang betul, correct orientation, jadi you tak boleh jadi winner. Sama juga konsep. For example, particle A must react with particle B first and then react with particle C to produce D. Okay, so you kena follow correct orientation from A, go to B first, and then B collide with C, and then after that baru you boleh produce D. So that is correct orientation to make sure that kalau you follow correct orientation, so reaction will happen. Okay, for activation energy, meaning that minimum energy that you need to initiate a reaction. Okay, so you can see that for activation energy, okay, activation energy, reactant particles need to have enough energy to initiate reaction. In other words, activation energy is required to start a reaction. Activation energy is like an energy barrier that needs to be overcome before a reaction can take place. Okay, so you can see from this analogy of activation energy. Okay, so nampak tak? The energy required for a host to overcome the barrier is identical to the activation energy that particles require to initiate a reaction. Okay, so reactant particles need to acquire the minimum energy known as activation energy so as to break the bond in the reactant particles and form new bonds in the product. Different reactions have different activation energy. Okay, so meaning that different reaction, dia punya activation energy also different. Okay, kita tengok this one, activation energy. Okay, got two type of reaction. The first one is exothermic reaction. The second one is endothermic reaction. Okay, right now we want to see energy profile diagram. Based on energy profile diagram, so you can see that which part represent the activation energy. So activation energy is this part. You nampak tak EA ni? Okay. Yang EA ni maksudnya adalah activation energy that reactant must have energy to overcome the activation energy. For example, this one is reactant, this one is product. So this one is activation energy here. Okay. So activation energy, for example, here is 200. Okay, 200 kilojoule that you need, for example. Okay, to make sure that reaction will happen lah. Okay, so kali ni 200, maybe sini 200. Okay, this one also nampak tak? Ini adalah EA, meaning represent the activation energy in here. So meaning that reactor must have energy to overcome this minimum energy, same or more than activation energy. Okay, the activation energy is represented by symbol EA in the energy profile diagram. The activation energy is the difference in energy between the energy level of the reactant and the energy at the peak of the curve in the graph. Okay, now you can see this one is exothermic reaction, this one is endothermic reaction. For exothermic reaction, total energy of the reactant, okay, total energy of the reactant here, okay, is higher than product here. But for endothermic, okay, for endothermic, total energy of product, okay, total energy of product, okay, higher than total energy of reactant. So you can see here, nampak tak line ni? Itu adalah energy. Okay. Total energy of the product is higher than total energy of the reactant. Okay. For collision orientation, okay, cikgu dah explain before, reactant particles must be in a specific orientation to result in effective collision. So based on this figure, you can see that collision between reactant particles in the correct orientation to allow old bond to be broken and new bond to form. Okay, for example, this one, the green one, okay, and then collide with the pink one, so it will result effective collision if got product is formed. So based on this one, you can see that the green one and then collide with the pink one, okay, in a specific orientation, okay, correct orientation, so it will produce the product. Okay, so the new product. So meaning that when it collide among each other, okay, between the green and the pink one, okay, old bond will be broken, and then to produce the product, it will form a new bond. Okay, for the second one, if the reactant particles collide in correct orientation, okay, incorrect orientation, okay, so the particle will bounce back and no reaction occur. Okay, so this figure show that collision between reactant particles in the wrong orientation. So if the in wrong orientation, they cannot produce the product. Nampak tak? Nampak the same. Before and after still the same. Compare to this one and then this one. This one new product. This one is reactant. But this one is reactant. But after that it become reactant back lah. Okay, maksudnya bukan become reactant back. It cannot produce the product. Okay. Effective collision and rate of reaction. Okay, the rate of reaction depends on the rate of successful collision between the reactant particles. Okay, successful collision, macam cikgu dah explain before this, there is effective collision lah. Meaning that there is collision between particles that can produce the product. So, can produce product meaning that reaction got happen lah. Okay, so the higher frequency of collision between reactant particles with enough energy in the correct orientation, so the faster the reaction occurs. In other words, rate of reaction depends the frequency of the effective collision. So, the higher frequency of effective collision, so higher rate of reaction. When the lower frequency of effective collision, so the lower the rate of reaction. Okay, so you can see from here, this one effect of concentration on the rate of reaction. So, this diagram you tengok for low concentration, okay, low concentration and high concentration. So, you nampak bila low concentration, the number of particles inside is lower than this one. Okay, so kalau you compare high concentration, so number of particles, okay, reactant particles is higher than this one. So, kalau you tengok yang ini, number of particles is higher, so possibility of particles to collide among each other is higher compare dengan this one. This one kalau dia punya number of particles quite low, okay, so the collision between particles, okay, is lower compare with this one. Okay, so the possibility collision between the particle is higher for high concentration. So, nampak tak? Okay, this one, effect of concentration on the rate of reaction. This one adalah point yang penting. Okay, so when the concentration of the reactant particle increase, so number of particle per unit volume also increase. And then frequency of collision between particle increase, and then frequency of effective collision between particles also increase, and the last one, rate of reaction also increase. And then same goes to the pressure for reaction involving gases. Changes in pressure in the same is the same as changing the concentration of the gas. Okay, so bila pressure of gas increase, number of particles per unit volume increase, frequency of collision between particles increase, and then frequency of effective collision between particles also increase, and last one, the rate of reaction also increase. And then effect of size of reactant on the rate of reaction. So, kalau kita guna when a large piece of a solid reactant is broken up into small pieces, the total volume of the substance remain the same. However, total surface area of the reactant increase. Okay, so you can see that from this diagram, okay, this one is block of solid reactant. This one is small fragments of solid reactant. So, nampak tak? Okay, only the outer layer of pink particles of solid reactant can collide with green particles. Okay. Kalau you compare for this one, increasing surface area, okay, enable more pink particles to collide with the green particle. Nampak tak? Green and pink, green and pink. But this part, they only from the outside ni je. Okay. Itu adalah dari segi effect of size of reactant on the rate of reaction. So you can see that when total surface area of reactant increase, total surface area exposed to collision increase, and then frequency of collision between particle increase, frequency of effective collision increase, and rate of reaction also increase. Okay, sama juga for effect of temperature on the rate of reaction. When the temperature increase, rate of reaction also increase. Okay, so this one is low temperature, this one is high temperature. Kalau high temperature, meaning that kinetic energy for the reactant particle is higher. Okay, compare with low temperature. Kalau you tengok pada, for example, kalau you ambil sugar, you letak dalam hot water and cold water. Which one is dissolved in water faster? For sure dalam hot water. Okay, sama juga yang ini high temperature, ni low temperature. Kalau high temperature, so kinetic energy for reactant particles is higher compared with low temperature. Okay, so this explanation. Okay, kalau when temperature increase, kinetic energy of the reactant particles increase, and then more particles have energy to overcome the activation energy. Frequency of effective collision between particles increase, so the rate of reaction also increase. And then effect of catalyst on the rate of reaction. Okay, catalyst is involved in a reaction but remain chemically unchanged at the end of the reaction. Catalysts allow the reaction to occur by providing alternative pathway with lower activation energy. So you can see this one, energy level diagram, energy level diagram. Okay, actually the blue line ni, nampak tak yang curve warna biru ni? Okay, itu adalah without catalyst. Meaning that the reactant, okay, must have at least minima, okay, activation energy is here. For example, katakan 200. Okay, katakan 200 kilojoule per mole, for example. Okay, so meaning that you need 200. Tapi if you put a catalyst, okay, it will provide alternative pathway by lower the activation energy, so that kalau yang ini after you add the catalyst, okay, this line is alternative pathway, so meaning that you need activation energy lower from the original one. The original one is without catalyst, and then after you put catalyst, so dia punya energy, activation energy is lower from the origin. Sama juga macam yang ini, you tengok this one, okay, kalau without catalyst, for example reaction, okay, reaction to produce the product, ini without catalyst. Tapi bila you letak catalyst, dia akan provide alternative pathway. So bila alternative pathway tu, meaning that the lower activation energy. Maybe you need 200 kilojoule. Okay, but if you put catalyst, maybe you only need 100 kilojoule. Okay. This one for effect of catalyst on the rate of reaction. And the catalyst ni dia remain chemically unchanged at the end of the reaction. Okay, dia tak berubah. Okay, in the presence of catalyst, catalyst provide an alternative pathway by lowering the activation energy, so more reactant particles can achieve activation energy. Frequency of effective collision between the particle increase, so the rate of reaction also increase. So for example, katakan macam you lompat tinggi kan. Okey, katakan 10 meter. Kalau 10 meter, maybe dalam 2 atau 3 student je yang boleh lepas lompat tinggi. Tapi kalau you reducekan dia kepada 5 meter, so maksudnya maybe dalam 5 or 6 student boleh reach dengan 5 meter ni, dia boleh lompat tinggi. Tapi kalau you reduce lagi pada 1 meter, okay, so maksudnya maybe 10 atau 20 student yang boleh lepas lompat tinggi tersebut. So same goes for this one, activation energy. Okay, ini exothermic reaction and endothermic reaction. Okay, chemical reaction ataupun reaction, dia ada two type of chemical reaction. There is exothermic and endothermic. Exo and endo. Kalau exothermic, dia adalah release heat energy to the surrounding. Meaning that during the chemical reaction tu, okay, dia akan release heat energy to the surrounding. But for endothermic reaction, during the reaction, okay, they absorb heat energy from the surrounding. Okay, so this one is energy level diagram for exothermic, and then this one for endothermic. So you have to remember how to draw the energy level diagram for exothermic reaction and endothermic reaction. Okay, this part, left side, this one is reactant, and then this one is product. Ini reactant, and then this one is product. Okay, so the change in the energy content that occurs when reactant are changed into product known as heat of the reaction, and is represented by the symbol of this one. Okay, so kalau exothermic, dia punya simbol adalah negative. For example, delta H equal to negative 200 or something. And then for endothermic, okay, heat change, okay, adalah positive 200 kilojoule per mole, something like that. Okay, so dia punya simbol, dia punya sign adalah negative for exothermic, and endothermic adalah positive. Okay, positif value positif. Yang ni pun value dia adalah negatif.